Pluto is one of the most mysterious bodies in our solar system. For years, it was considered the ninth planet of the solar system, until in 2006 it was reclassified as a dwarf planet. Even after this change, Pluto remains one of the most enigmatic objects for astronomers. Its eccentric orbit, icy composition, and thin atmosphere challenge scientists' understanding. But what would really happen if we could approach Pluto directly and survive its immense cold and complexity? Pluto is not just a distant frozen planet. It is a key to understanding the birth of the solar system and perhaps even to learning more about other stellar systems. Stay until the end, because I will reveal a secret that few dare to imagine about this cosmic enigma. First, let's analyze what we know about Pluto. Exploration of Pluto became more intense with NASA's New Horizons mission, which was launched in 2006 and passed just 12,500 kilometers from Pluto in 2015. However, even with this probe in operation, much about Pluto remains a mystery. Pluto is located more than 5 billion kilometers from Earth, in a region of the solar system known as the Kuiper Belt, filled with icy bodies and comets. Its extreme distance from Earth is one of the first obstacles to exploration, as a mission to Pluto takes years to arrive, and communication with Earth takes hours, if not days. The journey to Pluto is not simple. First of all, it requires meticulous planning, involving not only the launch of powerful rockets but also the calculation of extremely precise trajectories. The New Horizons mission, for example, traveled 5 billion kilometers, a distance that required accelerating the spacecraft to reach the necessary speed to get there. And even after the probe's arrival, communication with Earth takes a long time, as signals must travel billions of kilometers at a speed limited by light. In 2006, the New Horizons mission was launched from Cape Canaveral, Florida, with the goal of exploring Pluto and its moons. The launch was timed to take advantage of the launch window, a rare opportunity in which the relative positions of Pluto and Earth would allow a faster and more efficient trajectory, using a gravitational boost from Jupiter. This allowed the probe to reach Pluto in just 9 years, something that would have been impossible without this gravity assist. A powerful spacecraft is essential because Pluto's environment is extremely hostile, with average temperatures of -230°C and an almost non-existent atmospheric pressure. Any spacecraft approaching Pluto needs to be designed to withstand these extremes. Moreover, conditions in interstellar space make it even more difficult to ensure the spacecraft survives intense cosmic radiation, solar winds, and the extreme cold of the Kuiper Belt. When the New Horizons mission approached Pluto, it revealed a surface full of surprises. The first notable discovery was the vast frozen nitrogen plain called Sputnik Planitia. This plain is one of the most remarkable features of Pluto's surface and is filled with geometric structures that challenge the previous view of Pluto as a world without geological activity. The mission also revealed mountains made of water ice, reaching heights of up to 3,500 meters. This raises a fundamental question: how can such a distant, cold planet maintain geological activity? The answer may lie in internal processes that we still do not fully understand. Another surprising fact about Pluto's surface is the presence of craters, valleys, and even evidence of ice eruptions, suggesting that at some point in the past, Pluto had some form of tectonic or volcanic activity. This phenomenon raises the possibility that Pluto has internal heat sources, probably generated by gravitational interactions with its largest satellite, Charon. This type of heating caused by tidal forces could be responsible for keeping Pluto geologically active, which is extremely rare for a planet so far from the Sun. It is fascinating how the discoveries made on Pluto, such as the presence of vast ice plains and frozen mountains, challenge the idea that Pluto would be a dead planet. Scientists now speculate that due to its warm core, Pluto may still be undergoing dynamic geological processes which keep its surface renewed. This internal heat may have been preserved since the planet's formation, or it may even be generated by gravitational interactions with the moon Charon, which exerts a tidal effect on Pluto. This type of process is rarely seen in celestial bodies that are so distant and small. The study of Pluto also raises questions about the interaction of gases in its extremely thin atmosphere. Even at such low temperatures, Pluto's atmosphere exhibits dynamics that suggest climatic activities, such as winds and variations in gas densities. This is significant because, unlike other frozen and distant bodies, Pluto's atmosphere not only exists but actively interacts with sunlight, changing with the seasons. Pluto's atmosphere is one of the most intriguing aspects of the dwarf planet. Although it is extremely thin and composed mainly of nitrogen, methane, and carbon monoxide, it still exhibits complex dynamics. Pluto's atmosphere is not static. It expands and contracts depending on its distance from the Sun, in a seasonal cycle that lasts about 248 Earth years, the time it takes Pluto to complete one orbit around the Sun. When Pluto is farther from the Sun, its atmosphere condenses and becomes denser. But as it approaches the Sun, the atmosphere warms and the gases expand. This not only affects Pluto's climate, but can also have a significant impact on the formation of complex compounds in the atmosphere, such as hydrocarbons. The interaction of solar radiation with the gases in its atmosphere creates particles that form a complex bluish haze, making Pluto's atmosphere one of the most interesting phenomena astronomers have ever observed on such a distant planet. Pluto has 5 known moons: Charon, Styx, Nix, Kerberos, and Hydra. Charon is the largest and closest to Pluto, with about half its diameter. A unique feature of the Pluto-Charon system is that both are in synchronous rotation, meaning each always shows the same face to the other. This is a relatively rare phenomenon, especially among bodies of such different sizes. Moreover, the center of mass of the Pluto-Charon system lies outside Pluto, making it in a way a unique binary system. Recent studies of Charon have revealed that it also has fascinating geology. Water ice on Charon's surface breaks into enormous blocks, suggesting that the satellite has undergone melting and recrystallization processes, possibly due to heating caused by gravitational interactions with Pluto. Furthermore, the New Horizons mission also observed that Charon has an extremely tenuous atmosphere composed mainly of methane, making its interaction with Pluto even more interesting. The gravitational relationship between the two bodies may also be responsible for internal heating processes on Charon, similar to what occurs on Pluto. Furthermore, the New Horizons mission also observed that Charon has an extremely tenuous atmosphere composed mainly of methane, making its interaction with Pluto even more interesting. The gravitational relationship between the two bodies may also be responsible for internal heating processes on Charon, similar to what occurs on Pluto. Despite the wonders revealed by missions like New Horizons, exploring Pluto remains an extremely difficult and dangerous task. Cosmic radiation, intense cold, and extreme distance make any attempt to explore Pluto a formidable challenge. Even in future missions, where more advanced spacecraft may be sent, scientists will need to ensure the craft is protected against these hazards. The risk of damage from cosmic radiation is one of the main concerns for any future mission. Recent studies of Charon have revealed that it also has fascinating geology. Water ice on Charon's surface breaks into enormous blocks, suggesting that the satellite has undergone melting and recrystallization processes, possibly due to heating caused by gravitational interactions with Pluto. Furthermore, the New Horizons mission also observed that Charon has an extremely tenuous atmosphere composed mainly of methane, making its interaction with Pluto even more interesting. The gravitational relationship between the two bodies may also be responsible for internal heating processes on Charon, similar to what occurs on Pluto. Furthermore, the New Horizons mission also observed that Charon has an extremely tenuous atmosphere composed mainly of methane, making its interaction with Pluto even more interesting. The gravitational relationship between the two bodies may also be responsible for internal heating processes on Charon, similar to what occurs on Pluto. Despite the wonders revealed by missions like New Horizons, exploring Pluto remains an extremely difficult and dangerous task. Cosmic radiation, intense cold, and extreme distance make any attempt to explore Pluto a formidable challenge. Even in future missions, where more advanced spacecraft may be sent, scientists will need to ensure the craft is protected against these hazards. The risk of damage from cosmic radiation is one of the main concerns for any future mission. The magnetic fields that protect Earth from solar and cosmic radiation are absent on Pluto, meaning any spacecraft or probe sent there will need to be equipped with advanced shielding systems to survive. Moreover, the scarcity of sunlight on Pluto makes it impossible to use solar power effectively, requiring alternative energy sources such as radioisotope thermoelectric generators. Now, the secret that few know about Pluto. Studying Pluto not only helps us understand our own solar system, but may also be the key to understanding exoplanets in other stellar systems. The composition, eccentric orbits, and atmospheres of Pluto and other dwarf planets can provide crucial information about planets in distant stellar systems. Some mathematical models suggest that planets in other stellar systems, especially those located at the edges of their solar systems, may have characteristics similar to Pluto. Therefore, studying Pluto can help reveal more about exoplanet formation and the conditions that could allow life to exist on distant planets. Pluto, with its eccentric orbit, surface full of geological mysteries, and complex atmosphere, is one of the greatest enigmas of the solar system. Even after being reclassified as a dwarf planet, it continues to fascinate scientists, astronomers, and space enthusiasts. Discoveries made by missions like New Horizons have opened a new window to understand this distant celestial body, but many questions still remain unanswered. Leave your comment below and don't forget to subscribe to the channel for more scientific discoveries and mysteries of the universe.